Hello students, welcome to ePhysics. Students, in this video we will be discussing the relation between the focal length of a spherical mirror and the radius of that spherical mirror. Now students, what if we take a sphere and if we consider a small part of it, this small part will behave as a straight line, and if we cut this straight line, okay, now let us consider we cut this straight line and we are drawing it like it, okay, over here. And if we polish one side of it, the outer portion of the this aperture, this side will be the reflecting surface, this will be the polished surface, okay. Now when we draw the line from the midway, we call it as the principal axis, okay. This is nothing other than the principal axis. This point is the pole, and this straight line, if we draw this is the straight line, this is the radius, so this point is the center of curvature and midway is the focus. So let us consider we have somewhere over here is the center of curvature, and midway between P and C we have the focus, okay, the focus. Now let us consider, students, we have a converging mirror, that is converging mirror. Now converging mirror is also known as concave mirror, okay, we can also write it as concave mirror. Now students, let us consider we have an object, okay, we have an object, and if we draw any parallel line parallel to the principal axis, what happens after reflecting, it will pass through the focus, okay, after reflecting it will pass through the focus. We don't need to draw the other other light rays, because we don't need to create the image of the object, we just need to understand the relation between the focal length and the radius of that curvature, okay. Now let us consider that the first ray, first ray parallel to the principal axis, obviously it will pass through the focus after getting reflected from the spherical mirror. Now what happens, students, if we draw any normal from this, if we draw the normal, it will obviously pass through the center, okay, we know this theorem. Now let me first change the color of it. Let me take red. Now students, if we draw the normal from center of curvature, it will pass through this, okay. Now let us consider this is point N, this is P, this is F, this is C. Now students, we know that angle of incidence is equal to angle of reflection, and if this angle is theta, therefore this angle will also be equal to theta, and this angle will also be equal to theta from alternate interior angle. Now theta plus theta is equals to 2 theta, therefore this angle will be equal to 2 theta, okay, 2 theta. Now students, in triangle, if we see in triangle CNP, okay, in triangle CNP, we can clearly see it over here that tan theta is equal to NP by CP, okay. Let us consider this is equation 1, and in triangle, the next triangle, let us consider FNP, okay, FNP. This FNP is equals to tan 2 theta. In this triangle, tan 2 theta will be equal to again NP upon FP. Let us consider this is equation 2. Now students, we have considered the small part of it, okay, small part of it, therefore the angles will be very small. So for small angles, tan theta is approximately equal to theta, and tan 2 theta is approximately equal to 2 theta, okay. Now tan 2 theta we have already found it in equation 2, that it can be substituted by the value that is NP upon FP equals to 2 multiplied by theta is equals to tan theta, that is from equation 1 we know it as NP upon CP, so we can write it as NP upon CP. This NP and NP gets cancelled, so we are left with CP is equals to twice of FP, okay. Now students, you can see it over here that CP is nothing other than the radius of curvature. Okay, radius of curvature, so we can write it as R equals to this 2 multiplied by FP. FP is nothing other than the focal length. Okay, so we can write it as the focal length S, small f. So we have come to the conclusion that radius of curvature is equals to twice the focal length. So this is the proof of it. We have found the relation between focal length and the radius of curvature. So this is it with the video. Thank you very much for watching.